Alport syndrome is a genetic condition that severely affects kidney function while often causing additional issues with sight and hearing. 1 out of every 50,000 people worldwide are expected to suffer from this disease, generally experiencing noticeable symptoms before the age of 30. The major presenting sign for this disease is hematuria, or blood in the urine, often accompanied by protein in the urine and eventually renal failure. Other varying symptoms include hearing loss, eye abnormalities, and smooth muscle tumours, though the last one is quite rare. Alport syndrome occurs due to mutations in the genes that encode collagen 4, a protein that forms structures called complexes in the basement membrane, a flaw that many cells attach to. Collagen 4 complexes can be created from 6 different chains, named alpha 1 to alpha 6. There are 3 classes of collagen 4 complex. The first class is found in all basement membranes, but is only present early in development. It is replaced by the second class by about day 150 of pregnancy. The second class is found in the kidney, lungs, testes, cochlea, and eye. The third class is also found in the kidney, as well as the skin, smooth muscles, and esophagus. 85% of people suffering from Alport syndrome have an X-linked mutation on the alpha 5 chain. This means the disease mostly affects men, and will cause problems with the second and third class of collagen 4 complex, as they contain the alpha 5 chain. Other variants of the disease also exist. They are more uncommon, but they may also be passed on to women. Collagen 4 mutations will lead to improper folding, resulting in rapid breakdown of the protein. As the second 2 classes of collagen 4 cannot be created, the embryonic class will persist. Unfortunately, this class is far more susceptible to protein-breaking enzymes and therefore will rapidly deteriorate. This is especially true in the kidney, where harmful oxidants and proteases are constantly passing through. The kidney filters blood through basement membranes. Collagen 4 maintains the structure and strength of these membranes. Weakness in the glomerular basement membranes will lead to the passage of blood, protein, and other substances into the urine. As with most genetic conditions, there is currently no cure. The primary methods of treatment involve slowing progression or lessening protein loss through use of blood pressure medication. Dialysis may be required eventually. This involves the artificial removal of toxins, water, and salts from the body, a function the kidney would usually provide but can't due to kidney failure. Ideally, a kidney transplant would be done, as it is rare for a transplanted kidney to fail in Alport syndrome. The other symptoms, such as hearing loss, cataracts, and growths, are dealt with independently, either surgically or using other interventions. With dialysis or transplant, the survival rate in Alport syndrome is high. The probability of survival will still be about 80% 10 years after kidney transplant. Without dialysis or transplant, death will likely occur within a matter of weeks.